This is the first derivative test. We've been doing the first derivative test. We didn't have to have somebody tell us to do a first derivative test. We've been doing the first derivative test. It says, the first derivative test for relative extrema. Let C be a critical number for f of x. That is, f of c is defined in either f prime of c equals 0 or f prime of c does not exist. Take the derivative, set it equal to 0. Take the derivative where it does not exist. Those are critical numbers. That's how we find our critical numbers. We've been doing that. Been there, done that. Then the critical point is, of c, f of c, is a relative maximum if f prime of c is positive to the left and f prime of c is negative to the right. Do I care? That says increasing followed by decreasing. F prime of c is positive, means it's increasing. F prime of c negative means decreasing. So here f prime is positive, here f prime is negative. A relative minimum of f prime of x less than 0 to the left and greater than 0 to the right. We know that too. That says decreasing followed by increasing. Decreasing followed by increasing. But in the calculus world, decreasing and increasing in a calculus world, in the algebra world, in the calculus world, this would say f prime is negative. This says f prime is positive. Decreasing means f prime is negative. Increasing means f prime is positive. Not a relative extrema if it has the same side on both sides. That means increasing followed by increasing, decreasing followed by decreasing. So f prime positive, f prime positive, f prime negative, f prime negative. In other words, I don't have a peak and I don't have a valley. Then it's neither. Well, that makes perfect sense. We don't need to have a test to tell us that, because we've been doing it all along. So here we go. In exercises 23 through 34, determine the critical numbers of the given function. Classify each critical point as a relative maximum, relative minimum, or neither. Maximum plus minus. Minimum minus plus. Neither plus plus minus minus. If we go to our number line, that's what we expect to see. So here we go. Domain here is all real numbers, so that's not an issue. So I'm going to set up a column over here so we can answer their question. Cn is the critical numbers, and this would be max, min, neither. I can't use MMN because I would know whether it's max or min, but I can just put max, min, and n if I would just want to say it's neither. So here we go. So the first thing I want to do is find the critical numbers. Find the critical numbers. I want to know where f prime of x equals 0, or f prime does not exist. F prime is going to exist everywhere here because his domain is all real numbers. Not going to be any problem. So f prime, I'm going to say f of x equals 10x to the 6th plus 24x to the 5th plus 15x, not x, t, to the 4th plus 3. I hate when they have different letters other than x's. That's why you don't see me using many other letters on my worksheets and handouts, because otherwise I have to go in and do what I just did, change the letter. So f prime of t is 60 t to the fifth plus 120 t to the fourth plus 60 t cubed. I want to take f prime, set it equal to 0. I've got a greatest common factor of 60 t cubed. This gives me t squared plus 2t plus 1 equals 0. 60t cubed times, this is t plus 1 times t plus 1 equals 0. My critical numbers would say 60t cubed equals 0, t plus 1 equals 0, t plus 1 equals 0, t is 0, t is negative 1, t is negative 1. But I only write negative 1 once, even though it appears twice. You only need it once. So two critical numbers, so I can put those here, 0 and negative 1. So I want to know, do I have a max, or do I have a min, or do I have a neither? Now, where f prime does not exist, is there any place f prime doesn't exist? In other words, does it have a denominator?
No.
No. So I don't need to worry about that. So on my number line, I put my critical numbers. Negative 1 and 0. Pull my test points. So I know that f prime of x equals, and it's sometimes easier to use the derivative in factored form. And what's t plus 1 times t plus 1? How can I rewrite that? T plus 1 what? Squared. So there's the derivative. I'll choose 1 as my test. I'll get 60 times 1 cubed times 1 plus 1 squared, positive or negative? '60 is positive. 1 cubed is positive. 1 plus 1 squared is positive. So this guy's positive. Second test point, 1/2. Now I'm going to circle them because I have a tendency otherwise to figure the, is 1/2 the right number? Negative 1/2. So x equals negative 1/2. This is 60 times negative 1/2 cubed times 1/2 plus 1 squared. Positive, negative 1/2 cubed is negative 1/2, negative 1/2 plus 1 squared is positive. Positive, negative, positive is negative. And negative 2, again I'm going to circle him because he's a test point. I also do him a different color. I have to save myself from myself. This is 60 times negative 2 cubed times negative 2 plus 1 squared. Positive, negative 2 cubed is negative. Negative 1 squared is positive. Positive, negative, positive is negative. Oh, Now, decreasing followed by decreasing. So negative 1 is what? Neither. Decreasing followed by increasing, 0 is a questions.